Okay, if you can hear any students in the background, they went through this big bridge question, gave out a bridge worksheet, which I think is on the calendar. So if you're at home sick or whatever, you can do this playing along. If you read through this, can you use exactly one bridge, use each bridge once, um, and hit all the points? So is it possible? I don't know why that's not erasing. So if I do this, if I try this, okay, I'm going to start at C. I'm going to go over here. Then I come across, and then I'm going to go over this bridge. Then I go over this bridge. Oh, I never erased this one. So far, so good. I'm looking pretty good here. And then okay, all right. Then I'm going to go over this bridge. Oh, now I'm in trouble. Because now, if I go over this bridge and then go over to this one, then I'd have to go over this bridge again. And we wanted to do the thing that's been our idea about graphs of, using every edge only once. And what third, second, and first figured out through working, if they did, that they weren't able to do this. They weren't able to use every bridge exactly once and also use all the bridges. So then what that pertained to, if you print the worksheet and do all this stuff here, I'm just talking as, hopefully you can hear students in the background, so I'm assuming they're working. But this guy over here is talking about something at 12 o'clock, which has nothing to do with bridges, so go back to what you're doing. All right, now I got to press pause. Oh, these kids. All right, and then pretty soon we're going to get to them there. Okay, here we go. So then when I did this first one, the spirit of the bridge question, can I, and then we're going to make some conjectures, do it if the bridges were like this drawing. So I think I started here with this one, and then I went this way, and this way. So I never had to lift my pencil. So this is in the spirit of the bridge question. I use every bridge once. And according to the directions, here's the starting vertex, and I finished here. So then this is a conjecture that's going to come about this, and this is what we're going to discover in the class. As long as everyone's working, I had to do a little intervention of bums that just do everything but work on math. But anyway, how many even degrees are in this drawing? And we went through that in class, 2, 2, and 2. So there's 3 vertices with even degree and none with odd. And we discovered or remembered from yesterday, when you start at a vertex and then end at the same one, that's called a Euler circuit. So now what they're all working on is what happens with the rest of these drawings. What are the degrees of all the vertices? Do you end up with an Euler circuit or an Euler path? Are you able to trace and use all the edges exactly once? So on and so on and so forth. So they're doing that right now. I'm stalling because I wanted them to work on that. It's go time because the tape, I want to make sure I get a lot of stuff in here. And, okay, this group is fighting right over here again. All right, so group response, please be better than some of the others. A lot of people don't say anything. What are the degrees of B? Like, what's the degree of this vertex right here? I circled it. Oh, it's frozen. Let it go. Okay, this one that I circled right here. 3, what's the degree of this one? 3, what's the degree of this one and this one? So, we have 2 even degrees and 2 odds. Now the next question. Were you able to trace along all the edges and hit every edge exactly once? Yes or no? And the answer is yes, but maybe not right away. And I'm not going to do this for every drawing, but here's the spirit of it. Yeah, hasta la vista? Okay. All right. If you started here, okay, I go here, here, I'm already in trouble. Because if I go up, then I have to use another edge again. If I would have went here and here, then this one would have been left alone. So, okay, if you quit early, then you said, no, I don't have I wasn't able to do it. Well, what if you started here? You go up, here, 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 and here. So in mine, this was my starting, this was my finishing. If those that did this right, you either started at the top one, and that's where your S is, and then finished down at this one at the bottom, or have what I have. How many people have what I have or have them switched? And that's going to be the spirit of what actually happens here. What does this make this? Euler circuit or an Euler path? Which one is it? Uh-oh, we don't know our definitions from yesterday. It's an Euler path. A path, if you still don't know what you're supposed to know as you walk in here, is you start at one vertex, end at a different vertex, and use every edge exactly once. Every edge of the graph. Next one. What are the even degrees? How many even degrees do I have? Ruh-roh. Drawing C. Even degrees. 1. How many odd degrees? 4. And again, you are 2 days behind if you don't know what an odd degree is and an even. There's 3 edges coming from that corner, so that's odd. Odd, odd, and odd. Were you able to use every edge exactly once? Yes or no? Did you guys try? What was the answer? Yes or no? Actually, no. Your answer should have been no if you actually did this. Okay, so what you were supposed to do, and if you didn't, I don't know what to tell you. Okay? So I'm just doing something. I'm just going along here, and I'm okay. I'm okay so far, and now I'm in trouble. Because once I go to this edge, I either have to pick go left or go up, and then one edge does not get used. I don't care how you do this. There's always going to be one edge left over, or you'd have to use an edge twice to get the last one figured out. So is this an Euler path or circuit, yes or no? I did not use every edge, so is it Euler anything? No, it's Euler nothing. Okay, now, how about the next one, D? What are all these degrees? So they're all what? Even. So how many evens are there? How many odds are there? Now, if you would have started, and I'm not going to do this for every single one, I'm going to ask for answers from everyone, and you can check yourself. And if you're just writing answers right now, you're behind. You didn't go through the process like you were supposed to. You didn't listen to me, and I can't help you. Okay, 1, 2. Now I'm in trouble. Because now if I use that bridge, I can go ahead and do all this, but I can't reuse that bridge. So if someone quit and said it doesn't work, you should have tried something different. And then that gets into what your notes are today. Those that found a success either started here or started here. I don't know if you could see the pointer, but started here. Well, I don't want to use the bridge because I cut myself off. So I'm going to go this way. 1, 2, 3, 4. Then I'm going to cross the bridge and then do these. And I used every edge. And I started here and I finished here. What does that make that? An Euler path. And now we're getting into a conjecture. All right, but not yet. Let's do the rest. Okay, the next one, letter E. How many evens? How many even degrees? Uh-oh. So I don't think I had my class do this unless they just don't want to share. Are there any? 0. How many odds? Were you able to do the process? Were you able to hit every edge exactly once? No. And I'm not going over that. If you didn't go over that with your group, you're behind. Okay, how about letter F? How many evens? Well, let's do this. How many odds are there? Isn't this odd? Down here in this corner? And isn't this odd because it's ginormous? It's 5, correct? Aren't all the rest even? So, I have 2 odd, and again, this is the discoveries you should have made with your group. And then even, this one right here is 4, this little corner is 2, this little area right here, I know you can't see where I'm at, but that little area here is 4. All the rest are even. So what is that, 4? Did I count? 1, 2, 3, 4, 5. There's 5 even degrees and 2 odd. Now here's the question, and I would say this is the groups that were the most proficient. Were you able to do the process? Well, you would have been able to do it if you started at one of the odd degrees. So did anyone successfully use every edge once? Then you're ahead. If you start, so of course if I started at any of these other ones, you didn't know this before that, but that's the idea that we're going to hammer down today. If I started at one of these odds, I'm going to go ahead and start tracing. Start here and I go to there. I get rid of that weird one out of the way. Then maybe go here. Then maybe go here. I could even do the square. Let me get rid of the square in the middle. And then that ends me here, which allows me to go up this pyramid here, down all the way, and there I go. I started here, and I ended here. Notice what those 2 vertices are. They are both what? Starts with an O, and there's 2 D's in the word. odd. Did you see that? All right, and that's what we're going to have a conjecture of with this. So what is this called? An Euler path. All right, what's the next one? G. What are all of those vertices, I believe? Aren't they all something? They're all what? Oh my gosh, they're not telling me. I guess I'm on my own. Even. How many are there? 8 of them, I think? There's 8 of them, and none odd. And what were you able to do? Well, I could start here, let's say, this corner. I could go here. I'm going to stop. I'm going to get rid of that square. I just like getting rid of the square. Then I go up here, down here. Well, look at this. I'm excited. Anyone else? What does this end up being when I started here and I finished here? That is an Euler circuit. And I can't help you on understanding that definition. The last one. What are all of those vertices, I believe? I think they're all what? They're all even. How many were there that counted? I see 10. Okay, the ones in the middle. It's not going so well in here. Again, all on my own here. Did you get 10? Then why didn't you say it? I don't know. Okay, and then what did you end up getting? You ended up getting a what? I'm coloring it in yellow. No other circuit. Now let's make a conjecture. If you did the spirit of this worksheet, flip it over, but don't. Any observations about the relationship between the number of odd vertices and whether or not you can trace a network without lifting your pencil? Well, actually, I want more than that. Let's look at the yellows. What do you notice about all the Euler circuits? There is no odd degree in any vertex. What do you notice about the Euler paths? Not just more odds, there's something very specific that all 3 of them share. Exactly what? 2 odd. That's your notes for today. And that's what we're going to jump right into right now. Okay? Euler's theorem. If the graph has no vertices with an odd degree, no odd degree vertices, then it has not only at least, it has a whole bunch of different Euler circuits, actually. And you could start at any of the vertices for that graph, and you would end at said vertice. So, number 1. Okay, now I know it's 8 examples, and we're already making a conjecture. Well, yeah, we're going to do that. In those 8 drawings, 3 of them had the exact same properties, and they were Euler circuits. 3 of them had the exact same properties. Well, one property that was exactly the same, and they were all Euler paths. If the graph has exactly 2 vertices with odd degree, then it has 1 Euler path. That's actually kind of a lie, because we could start at one of the odds and end at the other, or vice versa. So that implies there's different ways to do that. But there's definitely no Euler circuit there. You can't create a circuit when you have 2 odd degrees. It just doesn't happen. Note to self on that Euler path. The path has to start at one of the vertices that's odd, and it will end at the other. Okay, and that's something you need to remember. And that's what I hammered down on, at first, maybe a couple of those drawings on that bridge thing. You got to fail. It failed. Well, try again. Oh, this one worked this time. It's because you started at an odd vertex. And that's why it worked your second or third try, for those that gave it that extra efforts. All right, I'll pause it, and then we'll continue shortly. Now these are like our formal notes. So pretend this was, this will be, your bridge thing was a worksheet, a little discovery worksheet. Now here's more of the same. Okay? So spend a minute to write that drawing down. Keep all the edges as is. And now we're back to the way we do things. The bridge example was bad because they didn't have vertices noted. They didn't have dots, and they didn't have letters marking them. Now we do. And just want you to be aware that these are not what's. What is this not? What is that? What aren't those right there? Those are not vertices. Now we're back to the rules. A vertice is only marked by a letter with a dot. Oh, for the love of dog. I don't know why that would happen. Okay? So spend a minute to make that drawing. As you finish the drawing, look at A. And the whole idea that I just tried to get out of this class in here was, the whole idea is what are the degrees? So then what could I have? That's what the bridge worksheet told me. So what's the degree of A? Almost said it. What's the degree of A? 2. And I can't help you if you can't figure that out. What's the degree of B? 3 edges. 3. Uh-oh. Put a star by that. Can we have an Euler circuit then? Yes or no? That's today's thing. No, Euler circuit's gone. All right, and then look at C. What's C? 5. Uh-oh. Let's move on. Right now, what could be possible, though? An Euler path. All right, how about D? What's D? 4 edges coming from it. E? 2. And then F? Why not? Same student. Apparently, others can't count. They don't know how to count edges, apparently. All right, 4. Hey, so what do I have? Now I have exactly 2 odd degrees. I have an Euler path, so that's why I kept this there, but I left Euler open there. I definitely have an Euler path. But what I need to do in order to create an Euler path is to start at B and then end at C. Those are the 2 odd degrees, or vice versa. That's what you know how to take notes, right? That these little 2 tick marks right here mean start at C, end at B. Anyone ever see that for note taking? Well, there you go. But back in the day when I was teaching at Providence, you taught at a non-public school. They had a note taking class for seniors, how to take notes. I thought that was interesting. Okay, so watch what I do. And I'm going to erase this arrow because I'm going to do something different than I did the other hour. What I'm going to do is identify the Euler path, and this is how you do it. You do it by listing the vertices, but also in a drawing, what you're going to have to do on a test is put numbers on your moves. So watch what I do. And I got to be careful. And everyone last year, those hooligans I was talking about, all did fine with this. And actually, the Fleury's algorithm that you took down, I'm not even going to show you what it is. I'm not even going to do it because what I found last year is we didn't even need it as long as we were careful because it is a little bit complicated. But I'm going to start at B. So I'm going to start at B and I'm going to denote Euler path. And how you do that is list the vertices that you move, but you also go to the graph and put numbers on your moves. And I'm going to go right to C. I'm going to do it. I'm going to put a 1 there. That's my first move. I think that's what I did first hour. Second hour, we started at C and did something different. Should be watching. Okay, squirrel. Then I'm at C. Now what do I do next? Well, I have a whole bunch. I could go here, 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 or here. I'm going to do this one. I'm going to go C to D. And by noting these numbers, I will be able to grade your work and just trace along. Did they denote a path? Is every fumble edge used? Now, I have 2 possibilities. I could go to C. I could go to B. I could go to F. I'm just going to go to F. So I'm going to put a 3 there. You could see how these answers could completely vary. But it's going to be easy for me to grade because all I have to do is follow your numbers. And through my tracing, I will be able to see that you've denoted an Euler path. So now I'm at F. I might do this. 4. Remember where I have to end, though. I have to end at C, so I'm at E. And when I'm going back E, when I look at C, I have 3 left over. So it is okay to go back to C right now because I could go to C, I could get out of it, and I still have 1 edge left over to end there. This is kind of like what Fleury's algorithm says. And I kind of ran into a problem last hour in our next drawing, and you're going to be able to get out of it. As long as you understand I have to end at C, you will be fine. So I'm going to go ahead and go 5 to C. And then I'm going to go 6 out of C to letter D. Fe to C to D. All right, and then I only have one way out of D because I've used 2, 6, and 3 in those steps. I've used those, so I have to use this one. 7 to B. And then I have to use 8 to A. And then I have to use 9 to F. And then I have to, because I used 4 and 3 here, I have to end at C. That's the last move. So what have I done? I've used every single edge. And actually, for me, for purposes of, okay, all right, this is what the student identified. This is what I'm going to do to grade this. Is this right? So I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every edge is highlighted. They've used every edge once. I know they've identified an Euler path correctly. And it's going to be very easy for me to grade. There are going to be so many different answers for this. So answers will vary greatly. And you need to understand that. Okay, all right. And then we already said this. If there is a graph that has 4, 6, 8, 10, anything more than 2 odd degrees, there's nothing. You don't have a path, nor do you have a circuit. That's an Euler path or circuit, is what I mean to say. So, big idea of the day. No odd vertices, you have an Euler circuit. 2 odd vertices, you have an Euler path. And we discover that through the bridge problem. Does it resume and then struggle on? Oh my gosh. Okay, there we go. Then all of a sudden it just shoots somewhere that I don't even want it to. All right, poor first hour. I let first hour write Fleury's algorithm, and then I remembered, you know what? We didn't even use this last year because it's a little confusing. But just look at it. Don't write. She's writing. I'm going to knock that pencil right out of your hand. All right? This is how you could do your homework. And I'll actually show this on the next example. Because honestly, what you're going to do, you're going to have to identify an Euler path or an Euler circuit, and you're going to see the drawing in front of you in the book. So what you could do is not copy the original, but look at the copy of the original in the book, and then do what I just did last example, drawing one edge at a time. So make a graph of the vertices only. So I'll show you in the next example. Choose a starting vertex. And then remember your rules. If I have a circuit, you will end at that starting vertex. If I have an Euler path, you have to start at one of the odd degree ones. You have to, or else you're done. And then what all this rest of this stuff is, you can, through just being smart and knowing what you have to accomplish, you can be okay here. So here we go. I know for no purposes you do have to do the drawing. So go ahead and do that real quick if you want good notes. There's the drawing. But do understand what I said about maybe a little bit of Fleury's algorithm. This is what the book has as a drawing. So you're just going to look at it. Okay, I'm going to look at this drawing. I see it. And then for my homework to identify an Euler path or an Euler circuit, I'm going to draw one edge at a time and then do the numbering. And I'll just do one edge at a time, and then I'll know which ones I used over here. Okay, so I'll give you a minute to make this drawing. There are a couple missing edges. And back to the spirit of the question, there are no intersections on the interior of this drawing. Those are overpasses and underpasses. Just using that as a term. Give you a second to make that drawing. All right, so here we go. What's the matter? This is what I would do. I know I said you can't, but right over here maybe the degrees. So you told me to write the vertices, Mr. S, not the drawings. But look at the picture here in the book. What's the degree of B? 3. And I'm not waiting for you. What's the degree of C? 1, 2, 3, 4. Right? 4? Make sure I don't make a mistake. What's the degree of 4? What's the degree of E? 1, 2, 3, 4? Good answer. What's the degree of F? 1, 2, 3, 4? What's the degree of A? 1, 2, 3, 5. So what does that tell you? I have to start at either A or B. I start at A. Where do I have to end? B. I'm going to start at A. Okay, Okay, so this is what Fleury's algorithm says. Okay, take your original drawing and like cut and paste your moves over here and then number them. So there's one. That's what I decided to do. And then I get rid of this. But again, that you'll be jacking up your book, right, if you do this? But kind of like keep a note to self, and then at the end, hopefully your drawing looks the same. And I have to start at A and end at B. But look at how many sides A has coming from it. So I think this is what I did last hour. I did all the outer edges. And I numbered them. 1, then 2, then move 3, then move 4, then move 5, and then move 6. I have so many ways out of A. I still have 3. So cross it off, or they say like erase it. That's not really practical, you know, if you're using pen as well. And then those are the leftover edges. Now, this is what you can't do. And I'm going to do it and then go back. Where do I have to end? I have to end at what? B. B only has one way back to it, right? That's all that's left. So if you did this, you are a silly, silly person. Why? Because then your next move is forced to be the B, and then how many edges didn't you use? A whole bunch. And this is what Fleury's algorithm takes care of a little bit. I got to go forward. Don't use that. Avoid it, is all I could say. You want to end at B. So sometimes you want to stop and see where you're at. All right, and then if I just avoid that edge, I should not go to A to E because it ends it. My last move is E to B, and then I'm done. Don't do that. Do like this. Something other than A to E. Oh, and I should be listing the vertices. Gosh dog it. So down here, I didn't do that the other hour. I went from A to B to C to D to E to F, back to A, and then I decided to go A to C, and then I put that there. So this is the move for it. And then I have to put, now the degrees I know are confusing. You might want to erase those because I don't, those numbers, I keep looking at those and I'm getting a headache. So there we go. That's 7. So I can put that 7 like right here, real tight on it, real tight. And then I have to go here. That's the only move that's left, so C to F. And then I could put an 8 real tight here, so I know that that's the move. Then I have only way out of F, which is F to D. And that's move number 9. And I could put that like below, I think, 9. And then I have to go, all right, D to A. So D to A. Oh, kind of missed that one. That's move 10. And then I have to go to E, which we're getting this finished off. That's move 11. And then I have to go to B, which is move 12. And the drawing is complete. And by Fleury's algorithm, as far as how I remove these sides, I've used every side because every side got crushed. Every side got deleted. All right? All right. Oh, and I forgot to write those letters at the end. Oh, crap. Okay, but I could, as the grader, do this. 1 move, 2, 3, 4, 5, 6, 7. Is that where I stopped? So now 8 is F. My bad, dogs. Oh, and it changed colors. I'm so confused. 9 is D. 10 is A. Why did he do that? 11 is E, and then B. And that is the listing of the vertices. Okay, now if you want some help on this, look at how you as the grader would be able to do this pretty easily. And this is my job. And I'm going to erase what I have here. This is number 27. And I think for letter B, you should make a drawing. Letter A, all you have to do is list the vertices. Very simple. They started at E, right? And then where did they go next as I'm pointing at this? Where did they go next? E. So you write E, D, then what? Then what? C, then what? E, and so on and so F, G, and that's how I can trace along, and I'm probably going to use a highlighter on your test to make sure you've denoted a path. And then as you're putting your stuff away, because I did say I was going to cover this with the other hours, look at what this says. It says find another circuit starting at G. So I'm going to start at G and using edge EC as the sixth move. This is why you have to write this down, because we got to renumber these sides. And they have so many people not paying attention. They're their own worst enemies. Own worst enemies. And I actually last hour came up with a couple of them. Watch. 1, 2, I hope I don't screw this up. 3, right? 4, 5, and then 6. Ding, 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 ding. Right? Didn't that just happen? Sorry for touching you. All right? Just trying to make sure that you are with it. Or watch this. I start at G. What did I do the other hour? I think I went like this. 1, 2. Oh, I'm nervous now. 3. I think I'm going to jack it up. I did. 4. So that didn't work. Don't cry about it. This is going to be embarrassing now. 1, 2, 3. Oh, no, that didn't work. All right, let's try another one. Maybe I shouldn't go down there. 1, 2, 3, 4, 5. You know what? There's another way you could do it. I found two completely different ways last hour. And if you saw what I just did there, just use that as the answer. But you got to keep going. All right. So I think for letter B, you redraw this with the numbers, and you better have EC with a 6 on it. I found one way, I couldn't find another one, and I just embarrassed myself. I'm okay. I'll still sleep tonight.